welcome all to our session on discussion with a guest in the course Digital Accessibility, where we are exploring technology, accessibility, and different types of inclusive design through the lens of our variety of guests. So, our guest today is Professor Volker Sorge. He's a leading researcher whose work sits at the fascinating intersection of artificial intelligence, accessibility, and maths. And he's a professor of document analysis and accessibility at the University of Birmingham. And he's also an adjunct faculty at IIT Delhi. His research has transformed how we make scientific and mathematical content accessible, from improving screen readers for math to developing AI tools that are automatically able to describe and translate STEM diagrams, so diagrams related to physics, chemistry, maths, into tactile as well as auditory formats. So he's collaborated with organizations like Google, MathJax, and the American Institute of Mathematics. And he's also leading his own startup called Progressive Accessibility Solutions, which uses AI and pattern recognition to push the boundaries of STEM accessibility even further. We would like to welcome Professor Volker to our discussion. Thank you for joining us today.
Thank you very much for having me. It's a pleasure to be here.
So probably we would like to start with some of your journey and the beginnings and what inspired you to get into accessibility. So you've studied maths, computer science, as well as philosophy. That's quite a unique mix. How did this blend of disciplines shape the way you think about accessibility and technology?
First, I wouldn't really say that it's a very unique mix because philosophy is underlying most of these scientific subjects anyway. One could argue that mathematics is just a philosophy of its own. So from that point of view, and computer science, of course, grew out of mathematics. So it's all kind of very much part of each other, I feel. Well, one thing is that I did mathematics and computer science. Of course, I studied philosophy as well. And then I did a PhD in AI. That was in the early 2000s. I finished my PhD. And at the time, AI was still very much part of what one could say cognitive science, which obviously has a big underlying philosophical component as well. So you not just think about how can I make something intelligent, how can I build an intelligent artifact, but you think about how does that actually reflect what goes on in our own mind? How can we actually model our own mind? How can we even understand how things work in our own mind? And from that point of view, if you ask me to what extent this pertains to accessibility, well, reception of particular visual phenomena was always something I was quite fascinated by. And so it is certainly an interesting question of how do we perceive things, and then how do people perceive things they cannot see, and how can we kind of give them the similar experience to what we see and what is quite easy for us to understand because we can see it. How can we give them a similar experience, although they can't see things, or they can't experience certain aspects of particular what we learn in the same way we do.
Interesting. So, but we would be very interested to understand, was there any specific moment or a challenge that sparked curiosity or inspiration to move into STEM content accessibility, particularly math content accessibility?
Right. Yes. So I'm a mathematician by training, and I was always interested in how to do mathematics on a computer. Right? And there's various ways how to do mathematics on a computer, and in particular, I was always interested in the full journey in a way from what is mathematics in, say, in a textbook, then how it creates a representation in our mind, and how can we actually model this on a computer. And then this was in those days was symbolic AI and was called computational logic. How can we model this? And so there is And if you're trying to understand what is, for instance, written in a textbook for mathematics and then try to model this on a computer, there are certain other application areas which are interesting, what you can use it for. For instance, one in those days, it was always interested for search, but also once you understand what actually the mathematics is, you might as well make it accessible for people who can't see it. And the main really pivotal moment in my life was when, we were always trying to kind of work on that area, but mainly we were working on the understanding part. Think about OCR, but think about OCR more for diagrams and mathematics. That's what I was doing with my research group. And I had a friend at the researcher at Google. Some people might know him. He's an Indian as well, TV Raman. And he just said, you've got a sabbatical coming up. Why don't you come to Google for a year and we'll try some of your ideas actually in practice as for accessibility, integrating mathematics, in particular for the Chromebox screen reader. And that really then changed my journey entirely, because from then on, the focus on accessibility for me became much stronger. It's also honestly a much more rewarding subject in the end.
Definitely it is. So you mentioned that about your sabbatical at Google and your work to integrate accessible maths models in Chromebox. I think similar approaches have gone into MathJax as well. For our listeners who may not know, could you explain what makes reading and interpreting math on a web-based application such a big challenge for assistive technologies?
What makes it a challenge is that mathematics is not like most other things you can read on a web page, which is fairly linear, where you can effectively read it from left to right. Mathematics you have to read two-dimensionally, and you have to understand what some of the relations between the symbols really mean. If you just kind of print the mathematics, regardless whether it's on a screen, i.e. on the web, for instance, or on a piece of paper, these relations are not really there. Right? So if you think about, how do we define relations between letters and words, for instance, you've got spaces between words and you might have the occasional punctuation and so on and so forth. That gives you an idea of sentence structure and so on. In mathematics, you really don't have that. In mathematics, you have to do this by understanding what some of these symbols mean and then interpreting this by what's the relation with the others. And that's the challenging bit. So if you see, say, an F with an open parenthesis and then something afterwards, is that F a function application, or is this F just multiplied to something in the parenthesis, or is this F a group element which is just acting on something, and that makes it challenging because it isn't there initially. So you have to interpret whatever is there, and then from this interpretation, you have to try to make it accessible as closely or as best as you can. You will not in all cases will you find the right interpretations, because sometimes it depends very much on the context and what the author has intended. But in many cases, you can.
So building on that, have there been moments where you have witnessed through your studies, through your experiments, where you have witnessed a positive impact of such a work, where persons or students with blindness were able to access math formulae better by using your models?
Yes, I have. Yes. So occasionally, most of my work is open source. So you get feedback through the usual open source channels. Most feedback is the obvious one, that when things don't work, but occasionally you get people just writing you very, very nice emails in a way, saying, yeah, this is fantastic, keep up the good work, or saying, I never knew that this was like this. I mean, this is more, in terms of the mathematics, I got a lot of these feedback, but there's a lot of feedback we get for graphics in particular, where people really tell you, well, I knew about these types of graphics, but I never, for instance, knew that they were kind of structured like this or constructed like that. And that is quite exciting, I always find, because this really shows that your work has some impact on people in real life. If you're a scientist, you're always hoping to have impact, but generally your impact means that half a dozen other people on the planet read your papers. If you do a work like this, which has then some practical applications on accessibility, then the impact is just so much more. It's more direct, and you can kind of get the human component behind it, which is always nice.
Yeah, definitely. I think it's very rewarding as well in terms of the work. So moving to how your current company, Progressive Accessibility Solutions, works on making STEM diagrams accessible using AI and pattern recognition. So what is the behind the scene processes and models, if you can shed a little bit of a light without revealing the IP, of course. Yeah.
So there's been a journey with the same journey everybody currently has for AI, of course, that we started out with what one could call more classical AI models in order to kind of pattern analysis, recognizing particular diagrams. Where you think about it, diagram consists of lines and letters and circles and things like this. So you kind of try to understand what are the basic geometrical primitives that are in the diagram. Then you try to localize these geometric primitives, try to understand the relationship between them. And then depending on the subject area your diagram is from, you can then start analyzing what that diagram really means. So think about it, if you have a couple of lines together and you have, say, two parallel lines and another line hitting those two lines in some point, and this is a molecule, then you've got a double bond and a single bond, and you might know that there's a carbon atom somewhere in this junction there. If this is a mathematical diagram, then it might mean something entirely different. And so from that point of view, you do the recognition, and then you try to do the interpretation, which gives it all the semantics.
So how do you, so I think you mentioned that the recognition and the interpretation are two different aspects of
two
it.
Very different aspects. Yes.
So of course AI is great at recognizing patterns, but how do you teach machines to understand the context or the meaning or the semantic aspects of the diagrams? And maybe training it on certain set of data may not be entire.
Yes, that is so. There's two ways to do this. One is trying to classify what things are, and therefore, with sufficient training to understand what's in there, and that goes back having effectively what we used to call an expert system, where you know how to interpret certain structures, and then you start putting these together. When it comes particularly to scientific diagrams, what's important about scientific diagrams is precision. So you really need to be precise in what that diagram means in order to tell it or to explain it to the reader, because there is a significant difference. For instance, if you have molecule structures, or there's a significant difference if you tell somebody, well, this is the molecule represents aspirin, or the molecule represents heroin. That is, although there might be structurally not that much difference. So there is no there is no error. You can't allow for any error anyway, anyways. So and therefore purely statistical models, I would say, or just models that work with classifiers do not always work. They can help, and they are very helpful these days, in particular to some of the more tedious or mundane tasks of the recognition. But ultimately, you need something that is actually precise.
So in this context, we would like to kind of explore a blue sky question. So how close we are to a future where a student could just take a photo of a whiteboard equation or a circuit diagram and have it instantly translated into an accessible format? How close are we to that future?
Closer than 5 years ago, I would say. So we've done quite a bit of experimenting with taking images from whiteboards, etc., working with color and all of these things. There is so we are pretty close to taking images from whiteboards and making them into very good graphics, which we then can analyze. When we're talking about making this instantaneous, if we allow for a little lag of a couple of seconds, then we're probably close. If we're allowing for no lag or very, very little lag, and if you want to have it really instantaneous, so it's like you get the same reading experience as a person in the classroom can actually see what's on the whiteboard. I think we'll be getting there eventually, but right now it's still it's still a bit of way off, in my opinion. But that might change tomorrow. Who knows what the next AI model does? I mean, that's.
So I think you did speak about how the models that you have been working on add audio kind of a layer to all of these diagrams as well as equation in order to explain it to a person who's visually impaired. Are you also exploring tactile feedback or haptic feedback?
Yes, we do. Not haptic, no. Haptic, I've never worked on that. So we do explore tactile feedback, in particular for graphics. I think it's important that people have multimodal access to it. Just listening to a graph or listening to a diagram is not generally sufficient. And having the experience of being able to touch something, to actually understand, what the boundaries of something are or what the corners are, or having a 3D way of putting together a 3D model of a molecule, for instance, is really, really helpful for students. But there's a certain synergy between the two. So, for instance, one particular pivotal moment for my work on chemistry was when we gave chemistry students at a school for the blind in the UK. They were chemistry students. They were GCSE at those days. At that time, they were 10th, 11th grade, and they were kind of stepping through molecules that they've never seen before online, just listening to them, stepping through them, understanding what the different components were, and then correctly building them in what's called molymots, which are effectively 3D, balls and double and single bonds you can stick together, and then and getting that right. And that was really something where I noticed, yes, audio descriptions of diagrams can be very, very helpful, but putting them together with other things like tactile feedback, with models and so on and so forth is certainly something that's important.
So have you, during your research, gotten an opportunity to do any longitudinal studies, like long-term learning impact related studies?
I have to admit, no.
Okay.
That is a shame. I always wanted to get this off the ground because, and this is one of my pet subjects, if I may mention that. There is certain different learning, particularly for mathematics and since you mentioned tactile, mathematical braille formats. There are certain differences in approaches, which I suppose are cultural, or there is. In many countries, there is particular math dialects, braille dialects for mathematics, right? Which are generally quite difficult to learn, and therefore add an additional learning curve, in my opinion. Which math is already hard, and then learning it, and a special braille for it as well is even harder. And there's a couple of European countries in particular where they now start teaching. Effectively LaTeX, which is a very, very kind of concise representation of mathematical formulas most mathematicians use, teaching the kids pretty much from year one to use that as a math representation with 8-dot braille, meaning that you really only have one character per character that you use, because it's effectively 8 bits. And I would love to have a longitudinal study around, does that really help in terms of will more children learn mathematics, and will they learn it easier, better, and faster than if they have to also learn an additional mathematical Braille dialect? That would be something I've always fascinated. But otherwise, I'm afraid no. Not. We're currently trying to do something a bit more longitudinal. We started working at a school in Hyderabad, Defna School for the Blind, and with a colleague of mine, Neha Chadraf, and we're trying to. So we just spent a week there working with them on tactile math graphics, as well as audio, as well as online drawing for mathematics. And now Neha will go back every week there and continue with these studies, as well as teaching them some of these techniques. And hopefully I'll be back in 6 months' time, and we'll do another study and see whether this is at all work and helpful.
So you have worked with several global organizations, which are like private organizations. Along with, you've also worked on the MathJax consortium. So do you recognize, and how would you like to tell our audience what is the power of open source, and how the mindset in such organizations like a Google versus a MathJax consortium differs?
Right. So first, before as a disclaimer, I would say, even while I worked at Google, I worked on an open source project. So Chromevox was fully open source. The math part, which I did in Chromevox, was open source, and that allowed me then, once I had left Google, to actually continue using this as a separate system, open source. So therefore, I don't think I can really tell you much about the mindset with respect to these things, but the only thing I can tell you about the mindset is that open source systems tend to live longer, I think, because if a company changes directions, and the product is being culled, or its product is being terminated effectively, then whatever you put into that product, or what is gone, and or will no longer be maintained, or it's being made open source, and somebody else on the outside can maintain things. And so from that point of view, that is, for instance, why I'm very happy that I kind of, after I left Google, I extracted my math part out of Chromevox into a separate system, because therefore it's still alive today, and now it effectively works with MathJax, but also other systems. And whereas Chromevox has gone through 2 different iterations, then I suppose it is now, I don't know, dead, I suppose. But
so what would you suggest that open source ecosystems such as MathJax or NVDA, all of those, how can they, what role do they play in driving accessibility or the agenda of accessibility in the tech world?
I think they play a crucial role. I think open source in general plays a crucial role in the development of software, because it simply is a way for people, not only for people to drive new and innovative technologies forward, but also for people to get involved. And I think that is important, that the bigger the ecosystem is, for people to get involved in, means that you actually can grow a community faster, and that you're no longer depending on a single player, which can kind of shut things off within from one day to the next, which is always a risk. Particularly if you're working with, obviously if you're doing something for profit, if the profit goes away, then the system will die. Whereas you can see that for a lot of these systems, that they still open source systems will be around for a lot longer. There are certain drawbacks to it. The thing is that one thing about open source is, of course, it's free, right? People can use it. Depending on the license, you can use it in your for-profit product, you can use it in a non-profit product, and so on. That gives, on the one hand side, gives opportunities for open source to kind of grow and also get sponsorship, as we do, for instance, in MathJax, as well as get people an income and a living out of their open source system, because they are the maintainers, or some people are the maintainers, and some people are using it, and they might put some money into it, and so on and so forth. On the other hand, the other issue is that many people who are using open source think, it's free, so all the maintenance has to be free as well. And that is a bit, so when you notice, and we notice that in particular as the maintainers of MathJax, is that there might be multiple systems involved in why things go wrong, but the first people complain to is the open source product, because we should fix this now, although the real problem lies with the non-open screen reader or the non-open browser or something like this. So that's always a bit frustrating, I suppose, but that's part of open source.
Yeah, good to know that. So you also have deep collaborative ties with IIT Delhi. How do you see the role of Indian institutions and other institutions in the global south in driving accessibility research at a global or worldwide level?
That is a very good question, and I should probably there's a couple of answers to this. I would just, in terms of innovation and in particular in terms of kind of progress, I think what's interesting in the global south is that it is, unfortunately, still low resource, and so it gives a good opportunity to develop accessibility or also just general assistive technologies that can help people without breaking the bank, without kind of going over the top, because there is a lot of need, and therefore there is a need to get things to people that cannot necessarily afford a very, very expensive solution as you can in other parts of the world. So from that point of view, I believe there's a lot of drive for innovation. And if you look at, so I've just been to a conference here at the IIT Delhi called Empower, where there were a lot of exhibitors that are really building very, very ingenious solutions for many assistive or accessibility problems, which are really, really good, but also not over the top and overly expensive. And the other thing is, of course, why in particular India is a good example of where new accessibility research can thrive, is because many things are new here in a way. They haven't been so accessibility, in the industry of accessibility, exists for many, many years, in particular in the US, in Japan, and in Europe, and so on. So there are certain drivers in there which kind of like to preserve the status quo.
I see.
Whereas here, you have a chance to actually learn from all these mistakes. And there, in particular, when it comes to STEM and math accessibility, there has been many mistakes over the past, in my opinion, at least. And we can forego those. And these can be avoided straight away. Instead, one can immediately work with much better, much more modern solutions than what has been done previously in other places. And so that is, I think this is a great chance, in particular, given how heterogeneous India is. It can become a fantastic model for the rest of the global south, because I give just the amount of languages you have here, the amount of obviously the number of people you have, and all of this, that just gives a very, very rich environment for important things like networking, propagating ideas, exchanging ideas, developing things that are particularly geared towards communities, heterogeneous communities, and that can be a fantastic model.
That is a good advice, I think, to Indian institutions. So let us move to some different aspects of your work. So as AI is becoming so central to not just technology development, but also digital accessibility in its own right, what are some ethical or design dilemmas that keep you up at night?
One thing I'm worried about in many ways is that AI is being dominated by a few players, and that is worrying because think about it. If particular AI for accessibility, you want a way to have an AI system which helps you not just while you're a student, not just while you're in this particular class, but something that will help you over time, that will adapt to your special needs, that will grow with you over the years, and that will help you then in your later life and in your professional life and so on and so forth, and kind of cater especially to your needs. That, however, means that it learns effectively exactly who you are. And when it learns exactly who you are, there is always the danger that this information can be abused. And if this information is then just in the hand of a particular company, which doesn't even tell you what information they have, that is something I would be concerned about very much. And yeah, and in many ways, there is something to AI which can be very, very helpful, particular for people with disabilities, but I think for everybody. But they also have to be able to individually control it and understand what's actually going on. And this is something which most people do not. And so in many ways, it is also an educational question. We have to start educating people from a very young age what they're working with, how these things actually work, and what's good and what's bad.
I see. So, in this light, how can we ensure that AI systems don't just automate accessibility, but also understand the diverse needs of, special users?
Well, when you say automate accessibility, it's already a question. What does that mean to automate accessibility? So when I automate accessibility and I say, well, I want to make, for instance, a document accessible, or I want to make a video accessible, or what does that really mean? So already there's the question, who's the user for whom I have to automate this? Right? Do I have to put subtitles in there? Do I have to put an audio description with it? Do I have to, do I have to speak out a diagram, and so on and so forth? So from their point of view, I mean, automating accessibility is intricately interwoven with the target audience already. So in a way, before you even do the automation, you need to know who you're going to talk to. And obviously, so I'm an advocate that everything should be in the content. So you don't have to rely on software X and special system Y in order to make things accessible for you. So from that point of view, it's more a question of understanding what the content is, then putting this together with the special needs of the user, and then deriving the right mode of accessibility, or of the right, how should I put this? The right mode or modality that you need in order to make it accessible for the particular user. And that's where AI should come in and really should help.
I see. Good to know all of that. So, but many of our listeners who are early career researchers and designers, what advice would you give them if they want to enter the world of accessible AI or document analysis?
What advice would I give them?
Like, what skill sets would they need to learn probably to still be relevant in the domain of accessibility?
Well, the obvious skill set is to learn how to work with AI, and in particular to learn how to review AI, because AI is fantastic. So I'm just from a thinking about a developing aspect, so AI is really fantastic in order to, it can write entire apps for you. But you need to be able to actually understand what it has written in order to be able to review it and really understand whether it makes sense for your particular concern. So from that point of view, what is still important is to learn the basics of your respective trade. That's always important. You have to learn the very basics of what computation is. You have to learn the very basics of design and so on and so forth, and then learn in what I would call this kind of separation of concern. What is the content? What is the styling? What is what is the computation? What is the functionality, and so on and so forth. And if you can separate these out, then you can actually understand how you can put them back together.
So in this light, what kind of breakthroughs do you think we'll see in the next 10 years, especially in making complex STEM materials universally accessible?
I believe that, that we can solve the majority of the problems in the next 10 years. I strongly believe in that, and I particularly believe in the possibility of solving those correctly, which is not always. I mentioned that previously. You don't always understand what the math formula really means because you have only a certain limited way of interpreting it. But given that you have the AI systems around that can interpret, for instance, the context in which a formula lives, or the context in which a diagram lives, or the entire scientific discipline that has led to the design of the diagram, that means that actually all this knowledge put together will allow us to actually fully understand that and therefore explain it properly to readers, as well as allow us to generate additional modalities out of things. Think about, you want things 3D printed straight out of the box, and you want things, I don't know, you want things tactile straight out of your research paper, and all of these things I believe should be possible. But there is certainly still a lot of work to be done for that. But in the next 10 years, I believe that certainly. It's ambitious, but well, maybe not that ambitious. It's probably maybe already in the next 5 years we can get to some of these things.
So finally, your company is called Progressive Accessibility Solutions. What does the term progressive accessibility mean to you personally?
I would read it differently. Not the accessibility is progressive, but the solutions to the accessibility problems is progressive. Okay. So the progressive solutions are things that I've started using technology like SVG on the web and various other things in order to make things accessible on a level that hadn't been done before. So so my strong belief is that the content should be accessible. As I said before, it's not going to have to depend on the software you're using, which operating system you're running, which plugin you've downloaded. The content itself should be accessible. So the progressiveness about it is to get as much content and as much information and as much semantics into the content and its representation as possible in order for diverse systems to be able to then exploit that and make it accessible for a diverse audience. And that, I think, is progressive. Or it was when I founded the company, which is already a few years back.
Good to know that. So Volker, this has been such an inspiring conversation, and you've shown us that STEM accessibility is not just about translating information, but it's also about rethinking how we represent knowledge itself. So from making mathematical notations readable by machines to teaching AI to see and describe diagrams, your work really bridges logic, design, and compassion. So before we wrap up, if our listeners want to learn more about your work or follow your latest projects, where can they find you?
my company, progressiveaccess.com, is the address. I don't do just work with my company. As that, we do work with MathChex, we do work with others. Where can they find me? Easiest right these days is just ping me on LinkedIn. Try to connect. Tell me what you want to do. And I'll be happy to answer it. And if I don't answer, that is not unusual. Ping me again. I'm very bad at replying.
Okay. Thank you, Professor Volker Sorge, for taking out the time and talking to us. And I'm sure our listeners have gained a lot from this conversation. Thank you, and we'll see you again in the next session of Digital Accessibility.